My probably most favorite feature in QCoDeS is the database storing. So with QCoDeS you are able to save your data automatically in the database, and in this video I'm going to show you how. As always, we start by importing the functions and the classes that we need in order to save our data or to store our data in a database. In order to do so, we first have to import all the different database functions. This is done by importing from QCoDeS the initialize database, which enables us to initialize our database, and the load or create experiment element. Furthermore, we will also use the format location function. So from QCoDeS.data location import format location. Another thing that we will also need is the import dat file, and I will come to the reason for that in a second. So from QCoDeS.data set.legacy underscore .legacy import, and then import that file. And as the last element, I also need the disk.io element or the disk.io function, which I get from the data.io. So I go to from QCoDeS.data.io import disk.io. Okay, so in order to save data into the QCoDeS database, we first have to understand how the different columns in our QCoDeS database actually look like. So we are working with a SQLite database here, which is basically a table database, which has a fixed amount of columns, and also you can add different rows. What are the columns that we need to use, or what are the defining parameters for our different experiments in that case? Well, we need an experiment, and we also need a sample name, because that makes sense. We are measuring samples in different experiments. So we first start by defining an experiment, and then we also need a sample. So experiment name, let's just call this DCIV sweep, and then we need a sample name, and in this case I would just call it a test resistor. Test resistor. Okay, the next step is that we need to define our database location. And in this case, we can, since we start with our first measurement, we can decide where to store our database. It is of course useful to take a drive where you actually can make sure that your data is staying stored. So maybe don't use a local drive, but rather a network storage where you don't lose any data, because there is some RAID levels or something like that which protects your data, or at least there are some copies or mirrors of your data. So in this case, we will do that by using qc.config, which is the config files of QCoDeS. Then we have to change something in the core. And what do we want to change? Well, we want to say we want to tell QCoDeS our new database location. And then we set the database location, and in this case, and this is a little bit sloppy, I will just store it in the same folder where I'm actually in right now. And in this case, I would rather suggest to use an absolute storage path, which doesn't mean that, which means you don't start with a dot, but rather with an absolute path. The next thing that we do is we initialize our database. This works by the command that we imported from above. And then we also want to load our experiment. So we say load or create experiment, and then we tell the experiment name, such as the sample name. Sample name. Okay, so this is basically what the basic setup looks like. We can also tell that the sample name is the sample name and the experiment name is the experiment name. And if we press enter now, we can see that this database is being created. Or maybe I did something. Maybe this is not possible. Let's try once again. Okay. So the database has been created now, and we started by defining this experiment. And there's also some way to look into that, and to look into the database, but I will come to that later on. Okay, so more important now, how do we save data into this database? Well, first of all, we have to produce data, and in order to do so, I will just steal the loop that I already defined above and run that very same experiment later on. And then something else that I have to do now is I have to save that data, to store that data. And in this case, I want to use a further dat file. That's also why I import this function up here, the import dat file, so that during the measurements I can already copy this file, and it's easier for me to make a small data analysis of the experiment while it's running. And then in addition to that, I also have the whole database with all the data in it, which I can later on use for my more sophisticated data analysis. So I'm kind of doing it in a dual way, that I have single files, and in addition I also have the database entries. So how does that work? Well, first of all, I take what I did above already. So I steal this one here, the data definition, but before I just take that, I have to define some new parameters. And the first thing is the location format. So I want to save my data in a folder which is called data in my actual path. This is actually now the path where I'm saving my DAT files, the DAT files. So I want to save them in a folder which I call data. Then I go by the actual date, so that I can sort it by the date which I conducted the experiment at, and then I use a number sign. Then I put the counter, which is the counter of my experiment, so the experiment ID. Then I use the sample name, and then then I use the name of the experiment. Name, and then finally I use the sample name. Okay, now I have to basically paste the values that I want to use for name and sample name, and this is being done with this RCD part, where I basically say name stands for experiment name, and then I have the sample, which means sample name. Okay, then in the next step I need a location provider. Provider is equal to format location, and then I take the format which I defined above, and then I tell it to use the format that I defined above. And then finally I also need the location, which is then again this location provider, and here I use now the disk IO in order to define my location, such as the record which I define by the RCD. Okay, so this is basically it, at least for now. The next step that I'm going to do now is I'm going to execute this one, and then I get a error because I have a typo in here. Record. Okay, now it's working. And in the next step now I need to save that data that I create over here inside my database. And this is now being done by this import that file. So maybe just a little bit of a explanation what I'm doing here. So when I'm running this loop now, maybe I can just simply do that by now. Loop.run. When I'm running this loop, I'm creating data. And this data has to be stored somewhere now. And this is what is basically being done right here. So I'm saving that data in this particular location that I provided before. This means in my directory, I'm creating a folder which is called data now, and a subfolder which is encoding today's date. And then I'm putting this counter, which is basically an ID, such as the name and the sample inside. So if I look into my directory now, I can see that I have this new folder data, then the date folder, and then inside of that I have the sweep. And the sweep actually includes the dat file, which is the sample, which is the data from my measurement, and also a snapshot. So I get basically all the different parameters for my loop and also for the different instruments that I'm using inside this snapshot here. And now I'm taking this dat file in the next step, and I'm importing that dat file into my database. And this is what happens in this last step. So I say import dat file, and then I have to tell it the location, such as the experiment that I'm doing. And then by just executing that, I should be able to import this into my folder. If I didn't do anything wrong here. So here it says sweep, and there it says DC IV sweep test resistor. Oh yeah. Okay. So then there's something wrong over here. So I'm defining here the experiment name and the sample name. However, I am not saving this data over there, but in a different location. And this is because of this get data set over here, which I'm probably also doing somewhere here. There, because I copied that. I copied this particular part of the experiment from before. Of course, instead of name, I have to put location location equals log in here. So if I rerun this and then I use this again. Oh, okay, maybe let's run it from the beginning again, because I probably confuse things over here. So if I'm running the same experiment again, now it should hopefully store that in the correct location, and then later on extract the file from the correct location and place it into my database. Okay, and here we can see we have set this value inside our database now, and we can simply verify that by using that exact same load or create experiment function again. And instead of creating an experiment, this time we want to load it. So I'm just using this, and I'm looking at the output, and here I can see that I already saved my first experiment in that database. By repeating that same procedure now, and I'm going to get that a little bit faster by increasing the speed in my loop a little bit, I will see that if I do the same thing once again, I have two experiments now inside my database. So you can see everything is stored inside a database. And that is a particular interesting asset also over a long time, not only over one PhD, but probably over several PhD theses, because you don't lose any data. And it also enables you to share data much easier than by just using files which you have to send around. So a database is a really cool asset, and I hope that it's useful for all of you and that you will be continuing to use these databases also in your experiments. And with that, I would like to end this video.